Welcome to Meteor Interviews, a series of interviews with Meteor developers. My name is Paul Dowman. This podcast is produced by OKGrow. We build web and mobile apps for clients using Meteor. You can find us at okgrow.com. Today I'm speaking with Matt DeBergalis, one of the authors of Meteor and a founder of the Meteor Development Group. Welcome, Matt.
Thanks, Paul. Great to be here.
So, Meteor reached a huge milestone about 6 months ago with version 1.0, and it seems like momentum and community support are picking up at an exponential rate. So my goal today is to learn about where Meteor is headed next. I think Galaxy might come up. Before we do that, though, maybe a really quick summary of how we got here would be interesting. So, what made you build Meteor in the first place, and can you sum up the major milestones of the journey so far?
Sure. I mean, it all began with a transition that's been happening the last few years, right, in how we write software. So we had for many years a web-centric world where most software was built as a server-side application. That application's purpose was to send down pages of HTML, right? So you go to Amazon.com, NewYorkTimes.com, Yahoo.com, whatever it may be, and you would interact with a piece of software page by page so that you could look at some text or some graphics, or of course got increasingly complex in terms of the user interface of those apps, but you would click a link or fill out a form and you'd wait a couple seconds and then you'd get a new page. So the page-based web took us from, say 2000 through 2012, 2013, 2014. And something started to happen around then, which was the rise of a very different kind of application that didn't feel like a web app at all because it used dialog boxes, it used modals, it had some sort of real-time or collaborative element to it. So think about an application like Uber, where you can watch cars drive around on the screen. You can in the middle of that application, open up a dialog box to be able to make a phone call or message the driver. The drivers can see where you are. So there's a very different character to that app, and it has nothing to do really with the web or the page-based model. The big driver of that is the rise of mobile devices, right? Because we now have these computers with us all the time, and those mobile phones and tablets allow us to have a far richer user experience because there's software actually running on the phone. And it lets us have this interactive user interface with animations, transitions, with some kind of character to the app where as the world changes, as other users are doing things, we see those happen on our screen in real time rather than waiting for us to click a link or move to another page before we see any of that. Yep. So the interesting thing is writing an application like that is a lot harder than writing an application for the web. A web app is really simple. It was a server-side program. You might use PHP or Rails or Spring or any of these frameworks that emerged in that era. But these are very different because now you have code in the cloud and you have code running on your phone. You have to support multiple platforms. So you have to support people using a web browser, but you also have to support, typically, you want that software to be installable as an app on iOS or Android. So a modern application suddenly looks like 4 separate code bases written in 4 separate languages, maintained by 4 separate teams. And those are the table stakes just to have something that feels really modern. Yep. That's caused a real problem because a startup or a consultancy or anyone who's delivering an application on a budget or who wants to get that application into the marketplace quickly is forced to choose between 2 really frustrating options. One option is build 4 separate code bases with 4 separate teams of experts in those areas and therefore spend a lot of money and time doing it. Or the other option is build something using a server-based web framework and miss out on the really great advances that people have made in the character and the quality of these apps. And we think the answer is JavaScript. So JavaScript is a really exciting language because it is the one language that you can use to write software that runs in all of those environments. We can write JavaScript that runs in the web browser, of course, and you're seeing entire applications now being written that way. You can use JavaScript in the cloud. That's what Node lets us do. So we can write server-side code written in the same language. You can use JavaScript now increasingly to write mobile applications using Cordova, using some of the new things that are coming out of, for example, the React Native project. So one language turns out to let us target all of those different pieces of a modern application. The problem with using JavaScript is that there's no standard platform behind it. And so that's really the genesis of Meteor. We looked around and we thought, what's missing here is what Rails brought to web development for the Ruby community, or what Spring, for example, brought to the Java community. It's a complete JavaScript application platform. So all the parts you need, from the different pieces of the SDK, the different libraries that you need to bring together to make an app, the tooling you need to glue those together and to maintain your build system, a way to distribute those pieces of code down to the phone, to do mobile updates, to do hot code push in your browser, and a story for how you're going to run that stuff in the cloud, right? So the complete picture, both code that we write and code that comes from thousands of community contributors in the Meteor package ecosystem. That's what a platform is together. And really the vision of Meteor 1.0 and what we were able to deliver last, I guess it was October, is a complete platform. If you've decided to write your application in JavaScript, that makes it easy to do that and makes it possible for a single team of developers to write that whole app.
Yep, that's exactly what brought me to Meteor, is looking for an entire platform when I felt we were doing a lot of work, gluing a lot of pieces together. So now Meteor is in the top 10 most starred projects in GitHub, and that's pretty incredible. You guys should be really proud of what you've done so far.
Well, there's, JavaScript is on the rise, let's just say, and it's really incredible to see the speed that's happened with. It's also a really unusual language in that it's the preference of people who are experienced developers, but also people who are just getting started or earlier in their career, or use software as a tool for a different career that they focus on. Yep. That's really atypical, right? Usually you see a divide between the languages depending on the experience level of the developer. So the rise of JavaScript, just start to finish, has been incredibly rapid, and so much exciting stuff has come out even in the last year or two that really fuel, I think, an excitement to be able to write applications this way instead of having to deliver these different pieces in different technologies.
Yeah, and I think that's one of the things that really marks the Meteor community, is that there's a lot of excitement. People are really, really stoked to be working with Meteor, and a lot of people that want to, that are just looking to do it. They're just looking for the excuse to jump onto it. So
right on.
So you're running a really successful open source project. I think that's clear. But you're also running a startup. So I think that must be an interesting challenge. You raised some money. You guys raised like $11 million, and so I'm wondering if first of all, you're doing two hard things at once. I think that's pretty amazing, and I'm wondering if they ever have conflicting priorities. How do you feel about that?
No, I think a startup is a great environment, or a company, I should say, is a great environment for building open source. If you look inside, not just Meteor, but MongoDB, for example, these are big, complicated software projects, and the ability to do that inside of a company where we can hire a team, right, where we can create structure around how to bring all the different parts that have to come together, not just the technical expertise, but also how do we talk about it in public, and how do we build a community around that? One of the first things we invested in, and we could only do this because we were a company, is a community program that I'm really proud of, where I think we had, 130 something different cities the week after we launched 1.0, each hosted a developer event on Worldwide Meteor Day. And
that was amazing.
Let me be really clear. That's the community. That's the community rising up to do something they're really excited about and share it with their friends. And I think I heard it was something like 4,400 developers came to Meteor Day right after the 1.0 launch. I mean, that's like the size of a WWDC or something, right?
Yeah.
So it's an incredible community, and it's being driven by people like you in Toronto and all across the world. But I think we have something to offer there, because as a company, we can help organize and coordinate a lot of that work. And we have a community team now of 3 people here at Meteor in San Francisco that are able to spend their time working with meetup captains around the world, working with people who want to give conference talks. So if you're a Meteor developer and you're excited about something and you want to give a talk at a local meetup or at a conference on JavaScript or whatever it may be, we can help you with that, right? We can help you with your presentation. We can help you schedule or organize or find a venue that would make sense. And those things, I think, can be really powerful if you use them the right way. So I think it's a model that's actually gained a lot of traction in recent years. Docker here in San Francisco is another example of an open source project that's backed by a company. And it lets us, in some sense, have the best of both worlds. I think open source is an incredibly powerful force. Meteor wouldn't make any sense any other way. You wouldn't build a closed sourced version of that. No. But being able to centralize a lot of the investment in what it means to have a JavaScript platform, and being able to build a larger team around that turns out to be a really powerful and important piece of the puzzle.
Yep, totally. So, but you have raised money, and at the end of the day, you need to earn some revenue in order to keep doing what you're doing for the community. So, so what's the plan for that? I mean, you guys have amazing T-shirts and hoodies. I think you could sell a ton of those.
Well, we've talked about this from really the very beginning. The plan is to sell Galaxy. So, it's not enough to be able to write an application. You also have to run that application in the cloud. And particularly for larger teams and in larger companies, the details that go into running a production application at scale in a secure and predictable way, and in a way that you can monitor, that ends up being an area where, number one, it's very difficult. And we'll get to that in a second. I can talk about why Meteor in particular is a interesting DevOps challenge for a company. And number two, it's a place that companies are, I would say, almost eager to spend money to help them do it well. So what we talked about, all the way back in I guess 2012 initially, and you can look at our original blog post on the website about this, is the idea of selling a commercial product called Galaxy that allows someone to run their Meteor application in the cloud, scale that application, monitor who's using it, control who has administrative access to it, and so on and so forth. And really solve a lot of the challenging DevOps challenges that come up with a WebSocket-based application. So, I mentioned that transition from the web era to this new stuff. So one way to look at it is from the perspective of the technology itself. The web era was all about HTTP, right? It's a protocol designed to let a server program send down a document, an HTTP document, an HTML document over the network, and it's request response. So everything we've done on the web for the last 15 years follows this model where the client asks the server for a thing, that thing is generated by the server, sent back down the network, and that's the end of the conversation. Right. So it's a stateless request response protocol. And a lot of the infrastructure for running websites in the cloud grew up around that paradigm. So this classic 3-tier architecture, the idea of a proxy server in front of an application server, all of that is really built around the HTTP model. WebSockets are different, right? Because WebSockets stay connected. So if I have a rich client code base that's running maybe on a phone, and that code is holding open a WebSocket back to my server code that's running in the cloud, I don't have the HTTP picture at all. I have something very different where I have a stateful connection that has to be kept open. If I don't have a WebSocket itself, I have to pretend I do by using long polling or some other technique, and I have to manage exactly how that works. So for example, I need to make sure that my client code always communicates back to the same server process because that virtual connection is stateful between the two. And a lot of the infrastructure that works well for the web era doesn't quite solve our problem in this new era of rich clients and cloud-based software. And that comes up in many different cases. But if you try to build that infrastructure yourself, you discover, holding open a bunch of WebSockets, like 1 million potentially, is a really tricky problem. Mm-hmm. Or another example is, because Meteor allows you to build these collaborative interfaces, and because we have data going over WebSockets, it turns out we need a way, and one of the key technologies in Meteor is a way to watch a database for changes. So this is something we call live data. And that means you have to have not just a database in your server that you can run queries against, but you actually need more infrastructure to be able to watch the output of that database for changes. And when you use Meteor with Mongo, this involves using Mongo's oplog, so the replication system built into Mongo, which plugs directly into the Meteor system and lets you see the changes in the database in real time and efficiently calculate what needs to be sent down to each client. Mm-hmm. So again, if you set up your Meteor application using web technologies, there's no answer for that. There's no story for how you're going to manage exactly how all those pieces fit together. And this turns out to be a really important part of Meteor's scaling story and Meteor's security. So there's an opportunity, there's a need, I should say, for cloud infrastructure that makes this stuff really easy, because you ought to be able to write a Meteor app and push a couple buttons and have that app running in the cloud. It's that simple. And that's what we are building with Galaxy. And the long and short of it is that's an area where companies are very, very excited to have a commercial relationship and be able to pay for something that solves a lot of those tricky problems.
Yep. So I understand that it's going to be easy to deploy. I mean, it's I suppose it's more considered a platform as a service as opposed to you're not providing a general hosting platform. You're providing specifically Meteor hosting. So there's been a lot of talk about how it will use Docker, and Aeronota and Justin talked about that on the Meteor Hacks show in depth last week. I'd recommend everyone to watch that. And I won't repeat most of it, but so if it's using Docker underneath, which is like lightweight virtualization or enforced separation of processes, really, how, as a developer, do I know you're using Docker, or is it more like an opaque platform as a service? Like, do I just do Meteor deploy and I don't know anything about what's happening underneath, or can I prepare Docker containers?
Our attitude on almost any of this stuff is that you shouldn't have to know the details to be able to use Meteor. Mm-hmm. But if you want, you can look inside and see what's going on and take advantage of the actual properties or the actual system behind the scenes. So let's talk about how Galaxy is going to work for a second. You're right, Galaxy is based on containerization. So what that means is that it is now possible on Linux, and this is a technology that we've had actually for a long time on other operating systems like Solaris, to run processes that are isolated from each other. So they're all on the same operating system, they're all using the same kernel, but we can carve out a section of the operating system that's only for a particular group of processes that don't get to see what other processes on the system are running. They don't get to see the network traffic or the memory of those other pieces. So you in a sense have a small chunk of a machine that's for your use. And because the chunks all share the kernel, it's a lot more efficient than using a whole virtual machine. So a virtual machine means every single separate little chunk has to have its own kernel, its whole operating system, everything, right? And that ends up costing a lot of overhead when you want to run lots and lots and lots of these chunks. So in Linux, we call these containers. It's actually built using a technology called C groups. And what Docker's given us is a standard way to talk about the file structure and the format of what one of these chunks looks like. So we call that a container. And in 2015, it's the natural and correct way to run many copies of a web process, for example.
Right.
So that's the first piece of the puzzle. Second piece of the puzzle is now that you've got many copies, and it's going to be possible that some people are going to want thousands of copies of their application running. And of course, there's going to be thousands of people all running their applications in the system. So you really are talking about tens of thousands, potentially hundreds of thousands of containers that are each part of someone's app. So you need to have a really solid way of assigning all of those processes, all those containers to a set of computers, actual machines that are going to run them. Mm-hmm. And we have selected a technology from Google called Kubernetes to do that. So Kubernetes' job is to take a pile of containers and figure out how to best run them on a pile of computers. So all that stuff is open source, and that's valuable because for the same reason we believe in open source, on the Meteor side where we talk about how you write your JavaScript, there's no one on the planet more aware of the challenges and the best ways of running a very large distributed application reliably than the teams at Google.
Yep.
And the ability to leverage that expertise by using Kubernetes as the foundation of what we're doing turns out to be really valuable, right? And it's a big reason why we went in this direction. So we're actually maintaining the port of Kubernetes to AWS, which is where we want people to be able to run their applications. That's the normal choice for most developers today.
Yep.
And what Galaxy lets you do is take your Meteor application, bundle it up for the piece that goes in the cloud, upload that into some set of containers that are orchestrated by Kubernetes, and then have a good dashboard in front of that lets you actually see what you've done, right? So you can log into Galaxy and you can see, here's my list of apps, here's how many of each I'm running, so how many copies, how many containers I have running. And then behind the scenes, Kubernetes is taking care of what actual computers are those running on. So that you don't have to worry about. And in fact, the whole concept behind a system like this is you don't want to think in terms of the particular allocation of processes to machines. That's not something that is under direct control in any event. Kubernetes makes its own decisions based on scheduling. It's just like you would never ask, which CPU on a multi-CPU machine is my process running on? I mean, sometimes in rare occasion, you want to have some control over that, but almost always that's just a detail of the operating system that you don't want to have to think about. So that's the architecture. And there's no secret that that's all built on Kubernetes and Docker. I think what you'll see is an increasing level of visibility into each of those parts. And part of the challenge here is Kubernetes is under development itself. And so figuring out what those interfaces look like and how to expose the different elements of that system and the metrics that you can ask of a Kubernetes system. So for example, how much CPU is each of my containers using, or how often or when was the last time a container had to be restarted because the machine it was running on became unavailable. Questions like that are going to be really interesting, and how we expose that to Galaxy users will be a big part of the story going forward.
Yeah, that's really cool. I think most platforms, most platform as a services do not provide that level of visibility right now.
Yeah, and that's a big theme, right? You want to build a modern cloud runtime on these key technologies that we can all trust and we can all understand. Because when you do that, an advance in how C groups in Linux works, or how Docker works, or how Kubernetes works, those are all things that the community as a whole can follow and that we can all take advantage of as they emerge. Our job at MDG is to figure out when is the right time to adopt each of these technologies, what is the right version of each of these to use, because, again, you can grab Kubernetes yourself off the shelf, it's open source, but I think it's charitable to say right now that would be a big challenge for most developers. It's not a polished product. There are a lot of very sharp edges. There's a lot there that doesn't come in the box. So just like the Meteor JavaScript application platform in some sense is all about finding technologies in the JavaScript ecosystem and integrating them well so that there's a complete platform, the concept of Galaxy in many ways is find the key cloud technologies that are best for running a WebSocket-based app in 2015, work with those people. We're very close to the Kubernetes team, for example, to make sure that they have all the right pieces we need to run Meteor apps really well, and then just bundle them together in a sophisticated way so that a developer doesn't have to understand each part to be able to take advantage of all the benefits of that model that you were just describing.
Yeah, for sure. For sure. To me, anything else is yak shaving. I'd rather just focus on building my app. I think it doesn't provide any value to our clients to beyond making sure that it's available and performant. That's all. And if someone else that doesn't provide any value to my clients for me to do that myself, if it's something that I can just pay for from a service. So we've been using Heroku for years, and Heroku has some challenges when it comes to Meteor apps. So there are other alternatives, but I'm definitely a big fan of just using a platform that you can just push to and have all that taken care of. So
the other point there, just since you mentioned that last example, is it turns out it's really helpful when there's a level of coordination between the framework and the runtime. So, I mentioned metrics very briefly. So, we might want to know, for example, how much CPU is my application using? And I might even want to see that on a per container basis. So I've got 10 copies of my app in the cloud. Here's the memory utilization or the CPU use of each one of those apps. But there's other metrics I want that are more about the internals of the framework, right? So I might want to know, and a lot of this is stuff that you can get from a tool like Kadira, is how many WebSockets are connected to this particular container, right? How many subscriptions are running right now? How many method calls are being made? So being able to provide the right hooks to pull that information out in conjunction with the operating system level information around CPU, around I/O, around memory, right? That's a powerful model. And that's very difficult to do if you don't have some sense of what's on both the runtime and the framework. So I think there's an opportunity here, and this is an example where it's difficult to do in a older generation of web frameworks, because there's great tooling for the DevOps side of the house where you're looking at the computer, the virtual machine, and there's great tooling for the application runtime side of the house where you're looking at my SQL queries and my stack traces from expensive requests. But there's a gap between the two. And I think the model where there's more of a what you might call a vertically integrated environment where all of that is designed in coordination, there's a chance to bring these things together. And I think that can be a really powerful tool for people to understand the behavior of their app.
Yeah, definitely. If you've used tools like New Relic and use them with one of their supported frameworks, like, for example, Rails, they give you a lot of visibility into what, how much time is spent in certain queries and in various different parts of the internals of Rails, only because they actually understand the framework. So, but then that's not integrated with the hosting platform itself. So I think there's really a lot of value you can add there. Okay. And so I just had one question that I wanted to ask before. Are you able to run other process types, or will that be kind of like a later version kind of a thing? So obviously you can have a Meteor app, and I assume it will provide Mongo probably as a service. But if you want to run something else, can you provide your own Docker container?
Our focus is going to be on a great experience for Meteor developers. I suspect that people will push the limits on that as quickly as they can.
Yeah.
So we'll see how that goes.
Okay, cool. So, and then I guess enterprise support is going to be probably a really big deal. So are you planning a behind the firewall version or anything particular for the more conservative type of enterprise customer?
Yeah, it's interesting. We're actually getting a lot of interest from larger companies that are looking at this stuff. And, they each have a different set of requirements. You can imagine there's a wide array of situations. Mm-hmm. And they have their own security situation. They have their own integration with other technologies that they've selected or that they've been using for a long time. So Here's the thing. The momentum is behind containerization, it's behind orchestration, and it's behind elastic public cloud. There's enormous momentum behind those trends. And it's, for the same reason that developers like you and I like it, it really helps a company if it doesn't need to make a big investment in some internal system before they can deploy an app. And you hear over and over again, if you talk to people, how difficult it is to deploy an app. Stunningly difficult.
Yep. If
you come from a tradition of using AWS or another public cloud to run your stuff.
Yep.
So, I think in the long run, we're going to need to support whatever environments our users want to run their apps in.
Yep.
But in the short term, my focus is on giving people a great experience deploying their application, running that application on a trusted public cloud provider, potentially a selection of them, and having a chance to scale that application as they need so that it can meet whatever demands they have on the number of people that want to use it. That's going to be our starting point. We'll go out from there, and there's a bunch of different exciting directions we can go, but I do want to keep the focus on that key use case to start.
Yep, that's great. Great, and well, you're on Gartner's cool vendors list, so I think that helps the enterprise people.
Yeah, isn't that cool? It's
that's awesome.
We're really excited about that. So it's interesting. It's another one of those examples I was talking about before where JavaScript's everywhere. It's not just the startups. It's not just the independent developers. It's not just the people that maybe used Rails up until recently and they've started switching over. We're seeing it in the enterprise. We're seeing it in other environments where you maybe wouldn't expect such a rapid transition to this new way of writing software. And I think the reason is mobile. There's such a powerful force forcing everybody to build their applications on mobile devices and to deliver an application that's like half as good as all this great consumer-facing stuff that we play with every night at home.
Yep.
And, Gartner, I think, is a firm that, their guidance is like, look, you should learn JavaScript. You should invest in teaching your team JavaScript, in picking up JavaScript-based technologies, because that's going to pay off in all of these different settings. It's just it's a smart chess move in some sense. It's positioning your pieces on the board the right way. Yep. And I think that, look, it's really exciting to be named cool vendor, and I think, we have a long way to go, but the idea that you can write in a single set of APIs, in a single code base, managed by a single team, the entirety of your application, the idea that you can take an app that you've always wanted but never had the time or the budget to build and be able to accomplish that quickly with a team of developers that just bring average, typical, standard JavaScript and HTML skills to the table, that is a really powerful idea. And I think that's resonating, really in large companies as much as it is with startups and consulting shops and the small teams that have traditionally adopted stuff really early on in its cycle.
Yeah, I mean, that's one thing that brings together people like myself that want to just build things quickly and also appeals to enterprise. I mean, it's return on investment. Spend less, build more, build something better. Totally. So
that's a great bumper sticker. Spend less, build more, build something better.
Awesome. So I want to switch gears to something else quickly. React seems to be generating a lot of buzz lately, and I don't know how much. Mm-hmm. I don't know how much of that is flavor of the month, and how much of it will last. But there seems to be something there, and at least they have some good ideas to learn from. I noticed you guys have been spending some time at least playing with it. So tell me what you think about React right now.
Yeah, like I said, there's a lot of interesting stuff happening in JavaScript. React's a good example. I think the rise of the reactive DOM as a whole, the rise of Angular and the excitement about Angular 2, or maybe I should say the spirited discussion about Angular 2. I mean, this stuff's all happening, right? And you can look at other parts of the stack too, right? The fork of Node and just the interest level in pushing the boundaries of what's possible with server-side JavaScript. I think another example is ES6. Now that the language is starting to take shape and most of the key pieces around modules and around classes and so forth have been settled. All of these are things that are happening quickly, and I think the way to look at a JavaScript application platform like Meteor is our job is to figure out the best way to use each of them and to package them together in a really well-designed way so that a developer can work on the interesting parts of their app and maybe spend less time on the glue and the work that needed to be done but isn't different between their app and anyone else's. So React is super interesting, right? I mean, it's our view engine is called Blaze, and when we first saw React, we were really excited because it has a similar approach. The idea of describing the DOM reactively in a declarative way and having the engine automatically drive whatever changes need to be made to the screen, and to do that in an efficient way is, I think, a really powerful component of a stack. There's some technical differences between how React does it and how Blaze does it. I'm not actually sure those are all that important. React, for example, uses a technique of a virtual DOM. So they do a diffing algorithm, and then they determine the minimum set of things that needed to be done to the actual screen to keep it up to date. Whereas we do that more directly. But, look, I think it's pretty simple. Developers are excited about this stuff. There's an emerging set of higher level componentry that's now built on React, which I think is especially exciting because the whole promise of Meteor from day one was you want to be able to build an app. You probably want to be able to use a bunch of off-the-shelf pieces for that. And there should be an ecosystem of declarative or reactive components, much like we had, an ecosystem of jQuery components from the previous era. So we're taking a look at how to make that integration work really well. The goal being, if you want to build your JavaScript app and you want to use React and the React ecosystem on top of that as your view layer, look, at the end of the day, you're going to need the other parts of the Meteor stack. You're going to need a data synchronization story. How do I get my information into those components? Information that lives on the server and information that other people are changing in real time. So there's been some discussion in the React community about some ways to do that. There's been some hints from Facebook about some open source stuff that may come along, Relay, for example, that addresses some of that. But we think that the data stack in Meteor is pretty much what people need. And so being able to glue those together is really exciting. So we're gonna take a look at that. And React's just one example of that. I think aligning, with ES6 is another great case where now that there's consensus in the JavaScript ecosystem about the right way to, define classes or around the right way to think about modules, it makes every bit of sense for Meteor to make that a first-class part of the platform. So that's another area where we're looking at. And those two fit very well together because I think the React community has also concluded ES6 is the way and the light. And so, look, if you want to write an app, here's just an example of where a JavaScript platform can really help you. Let's say you want to sit down and you want to write an app and use some ES6 features. The challenge is you have to build a tool chain around that before you can get very far. And it's not just a tool chain that lets you use ES6 by translating it into something like ES5 for your browser. You probably want source maps so that you can actually debug the ES6 in your console, right? And you want all this other infrastructure that goes along with the choice to use ES6.
Right.
And that's where we can be really helpful, I think, is that should come out of the box. And if you want to look inside and change exactly the way it works, that's reasonable. But most developers just want to use what's in the box, and they want to be able to build on top of those great features. So my focus is figuring out which parts of that to put in the box and how to tie them all together so that if I sit down and I want to build a React app using JSX and ES6 and a few components that I found from the React component ecosystem, that is as easy to do as building that application using templates in Meteor today.
Right. So David Heinemeier Hansen, the creator of Rails, he describes Rails as omakase, which means like the chef chooses as opposed to a la carte. So would that be the way you view Meteor? Like, do you want it to be an opinionated framework? I mean, I would say it appears to be less opinionated than Rails.
I think some opinions are good. Opinionated about ES6, yes, that makes a lot of sense. Mm-hmm. We should explain what the parts of ES6 are that make sense to use and the right way to use them. Opinionated about application structure. Here's something I think Rails did really, really well. Rails told you where to put your files and what to name them. Mm-hmm. And there's, in the early days of Meteor, we steered away from a lot of that framework level guidance, and that's in part because we were focused on building some of the key underpinnings, things like the data synchronization layer that don't have an equivalent in other web systems. Yeah. But I think it's pretty clear that that's valuable, and that's an example where I think we can offer some guidance. So if you want to build an app, and again, you want to do it in React or you want to do it in Blaze or Angular, we can still help you just determine how to structure your data flow through the app, right? How do you write not just a query, but how do you plumb that query into a component in a reasonable way so that you can understand how it works, and so that another developer can show up the next week and already have a basic lay of the land of how your application is set up. Mm-hmm. So yeah, I think you'll see a lot of that stuff, and it's really because the lower level details are now pretty well sorted out. Right? So we have latency compensation, we have data synchronization in place. Now we can build on top of that. Now we can build more of the framework level considerations around what's the right data architecture for a component-based app? What's the right approach for defining different modules or different components in your code base? Questions like that, I think, are going to be a really big part of what we work on over the coming 6-12 months. Mm-hmm.
So are you saying maybe you'd be opinionated about things where there's a clear choice, but if there's something where like the front end you use, whether it's Blaze or React, Angular, there's no clear like one choice there that everybody would want. So support it all.
I think opinions are good if they're right. Yeah. So this stuff is in flux, right? This is no pun intended, but there's a lot happening, right? And I don't think React is the flavor of the month. I think it's more than that. But it's not the only flavor in the store, right? Mm-hmm. We've got far more, I would suspect orders of magnitude more developers using Angular today. Yeah. I think it's really important that we select our opinions responsibly. So, and again, I think if you want a quick shorthand for what we do at MDG, it's exactly that. It's understand how all these different elements of the ecosystem are maturing and evolving and how they work together and where they don't, and then making good decisions about where and when to integrate, where and when to select as a default, and where and when to steer people in a particular direction to make sure that the act of writing an app isn't besieged by 1,000 little, paper cut decisions that you have to make about this, that, and the other thing.
Yeah, that's what I want.
Yeah. and you can, our promise to our developers is we will let you know when the right and what the right way to use some of this stuff is. And our guiding principle through all of it is what makes for the best developer experience for the user. What is it that makes it easiest and most productive for a team of people who know JavaScript and want to write an app to be able to accomplish that.
Yep. Great. Well, I think that's a good place to leave it. Thank you, Matt.
Sure. Thanks. enjoyed it.
So if our listeners would like to get in touch with you, how can they do that?
The best place is the forums. So we started a new Meteor forum a few months back. The spammers got us on Google, and we moved over to Discourse forum. So go to forums.meteor.com. There's room there for Q&A about the project, technical questions, a lot of which we also like to see on Stack Overflow, but the forums can be a good place to get a lay of the land. There's an area to talk about community and holding events. And of course, there's discussion about the technical direction of the project and different things we may consider putting in, or design reviews, or ideas for the future. So we really welcome anyone and everyone. I'm really proud of the community and the attitude that has let us have a place that someone who's new to JavaScript and new to programming can be as comfortable as someone who's been doing it, their whole life. So forum.meteor.com, forums.meteor.com is the best place to start.
Great. Yeah, I second that. The forums are really active, and I think.
And I should say, it'd be terrible for me not to say, if you're in a city with a Meteor meetup, and Toronto, of course, is one of them. Thank you, Paul. Go to a meetup. We've got a great set of events, and again, welcoming for everyone. We do one here in San Francisco every month that we broadcast over the net, Dev Shop, but everywhere across the world: Hong Kong, London, Toronto, San Francisco. If you're in a city with one, you should go. If you're not, get in touch with us. You can reach the community team, community@meteor.com, or on the forum, and we'll help you set up an event.
Awesome. Great. Thanks, Matt. Thanks for listening. If you liked this show, you can subscribe using iTunes or your favorite podcast app. For more info, visit meteorinterviews.com. To learn more about OKGrow and the work we do, you can find us at okgrow.com.